So the title of this talk is Relativistic Mass Does Not Make Sense. In a previous video, I asked the question, if a spaceship goes too fast, does it turn into a black hole? The problem being with the concept of relativistic mass. I have now been referred to an article dealing with relativistic mass. It's by Philip Freeman, teacher at Richmond Secondary School. So Freeman says, most short introductions to special relativity include the idea that the relativistic mass of an object depends on its velocity. And he then gives an equation. However, if you do much further reading in modern physics, you will soon come across the idea that this is a bad concept. And he asks the question, why? What is wrong with the term relativistic mass? Some answers to this are physical, some ideological. Here is an overview of the case for and against relativistic mass. Terms. One of the problems with talking about mass in this debate is that it is hard to even have the discussion when the term involved, especially mass, are what is under debate. I will, for the purpose of this discussion, refer to a mass of an object in its own frame, which the one school which used to call simply mass as rest mass. So there's a group of people who wants to just use the term mass and what they refer to as rest mass. And the change in mass due to reference frame, which the first school wants to banish and the other school tends to call simply mass as relativistic mass. So when he's talking about these schools, it's what different people want to say. One school wants to say mass is just rest mass, and another school wants to say something different. So what's wrong with relativistic mass? The physical problem is that there is no unique way to define relativistic mass and get consistent results. So my comment now, no unique way to define. So in other words, it does not make sense. And this is what has been taught to students, physics students, as something that does not make sense. Freeman carries on, the relativistic mass has to be treated very carefully, or you end up with odd concepts such as tangential mass versus radial mass. How can mass have direction, he then asks. In other words, it starts to make less sense. Freeman carries on, for example, when calculating the bending of light as it goes past a large mass like the sun, you might say that this light has a relativistic mass equal to energy E divided by the speed of light squared, and then use Newton's formula to determine how gravity affects it. This will give you the right answer if the light is moving toward or away from the sun, but it will give the wrong answer if you try to use it for light moving sideways past the sun. So my comment is, wow. So add the concept of relativistic mass to Newton physics for light bending by gravity, and you sometimes get the right answer for that bending. And then I carry on to say, not enough details are being supplied, of course, for what he's saying here. Freeman carries on, this gets even worse when we get to general relativity, as you might expect given the example above. In general relativity, there is no unique, consistent way to define mass at all. In many special circumstances, there are useful versions of mass, but different ones for different circumstances. So you start with the concept of relativistic mass and move on to general relativity, and it all ends up a mess. Freeman carries on. For now, we will focus on special relativity. Given how easily the concept of relativistic mass can lead to confusion, some physicists, especially particle physicists, have championed the idea that the term mass should only mean rest mass. And that's one group of people school refers to. They want to just refer to mass now as being rest mass. And that is, in other words, they want to abandon the concept of relativistic mass despite the many years it has been taught to physics students. Freeman carries on, he says, rest mass is a relativistic invariant, at least in special relativity, and in physics we generally seek invariant qualities as being in some sense deeper than observer-dependent ones. It therefore makes sense to focus on this and avoid all that confusion. Thus, these physicists conclude that is what everyone should do. So now he wants to talk about an invariant theory instead of a relativity theory. And I'll give him one of my video talks on that, and I'll explain the confusion caused by that. So the video is called Einstein's Relativity, the Misnomer. Some people want to treat Einstein's relativity as really just dealing with invariance instead of things being relative, because people, when you talk about a relativity theory, you think, well, everything's relative, when in fact not everything is relative. Some things are supposed to be invariant. So the term relativity for Einstein's relativity theories, that leads to a big deal of confusion on itself. The issue being at the moment in this video, relativistic mass is relative, and now they want some revision that mass is an invariant has been only rest mass. Freeman carries on, but what is rest mass? Question mark. This is a little tricky because the mass viewed in this way is not a property of objects, rather a property of systems. And I note the word tricky, i.e. it's getting worse. I doubt if physics students have been taught that rest mass is tricky. The poor physics students are just being deceived. Freeman carries on. The rest mass is the mass of a system in its centre of mass frame. If the system as a whole is moving, then its overall kinetic energy is not part of its rest mass, but the kinetic energy due to internal motion is part of the rest mass. This is analogous to the idea of internal energy in thermodynamics, where the overall kinetic energy of a system as a whole is not part of the internal energy, but the hidden internal kinetic energy of the particles that make up the system is part of the internal energy. I find all that very confusing, what's just been said there, and it's not something I've been told when I've been taught relativity, so it's just something that's probably omitted from being taught to physics students again. They're not told all this mess with rest mass. Freeman carries on. What's not wrong about relativistic mass? Question mark. The declaration that we should banish the term relativistic mass is where the political element of this debate manifests. Each perspective on the meaning of mass has its positive and negative aspects, and to argue that either one is the one true way is not really a scientific or even a pedagogical choice, but an ideological one. So basically what he's saying, they can't agree. So if you keep relativistic mass, there are good reasons for keeping relativistic mass. If you get rid of relativistic mass, there are good reasons for getting rid of the idea. So what do you do with that? It's just a mess. Freeman carries on. The idea that only rest mass is itself subject to misunderstandings and misconceptions. So if you just want to keep rest mass and get rid of relativistic mass, things are just still going to get worse. And as he continues talking, things just get more and more worse. So now just jumping to his conclusion. Freeman says, a general suggestion. Physics is and should be a multicultural place, just as Canada aspires to be a multicultural country. And I think the same precepts apply. Whether you view the idea of relativistic mass as useful or harmful, it is perhaps best to recognise that cultural diversity can enrich your understanding, and we don't have to have everyone conform to one point of view to work together. And he carries on, and maybe if we teach our students that these different perspectives exist, they can learn that lesson too. Peace, order and good physics. So my comment is, teach our students that they are different, that these different perspectives exist. Now that's something the educators are not doing at the moment. As I have pointed out in previous videos, experiments such as the Michelson-Morley experiment are taught as should be interpreted by Einstein's relativity, and there is no mention that can be interpreted by other theories than Einstein's relativity, thus giving a false impression to physics students that it can't be interpreted by other theories. And now suddenly we are in this relativistic mess with relativistic mass, and he's talking about, well, we should appreciate there are different perspectives. What different perspectives even within Einstein's relativity? What you're talking about is generating a terrible mess. So that is the end. Finished. Thank you.